What if I told you a massive asteroid was hurtling towards Earth? Imagine the sheer size and speed of this colossal space rock, a silent harbinger of potential doom, racing through the cosmos with our planet in its sights. What if I said this space rock, a silent, invisible threat, had our name on it? It's not just a distant possibility, it's a scenario that scientists take very seriously. Sounds like a bad sci-fi movie, right? The kind where heroes save the day at the last minute. But unlike the movies, we can't rely on a scripted happy ending. But here's the thing. It's not entirely fiction. The threat of an asteroid impact is a real and present danger, one that has shaped our planet's history and could very well shape its future. Asteroid impacts are a real danger, a threat to our planet lurking in the darkness of space. These celestial objects have the power to cause widespread destruction, altering landscapes and ecosystems in an instant. We often look up at the night sky and see a sea of tranquility, a cosmic ballet of stars and planets. It's easy to forget that this serene view hides countless dangers, but the universe can be a chaotic place. Amidst the beauty and wonder, there is also unpredictability and peril. Asteroids, remnants from the solar system's formation, zip around, sometimes crossing paths with Earth. These ancient travelers hold secrets of our past and potential threats to our future. Most of these are harmless, burning up in our atmosphere as shooting stars. They create beautiful displays in the night sky, a reminder of the universe's grandeur. But some are big enough to cause serious damage. These are the ones we need to watch out for, the ones that could change life on Earth in an instant. We're talking city-destroying, tsunami-triggering, potentially civilization-ending events. The good news? We're not sitting ducks. Humanity is not without hope or defense. Scientists at NASA and around the world are working hard to protect our planet. They are constantly monitoring the skies, tracking near-Earth objects, and developing strategies to mitigate these threats. They're developing incredible technologies like something out of Star Wars to deflect asteroids and prevent a cosmic catastrophe. From advanced telescopes to innovative deflection missions, these efforts are our best bet to ensure Earth remains safe from a cosmic bullseye. 66 million years ago, an asteroid the size of Mount Everest slammed into Earth. The impact triggered wildfires, tsunamis, and earthquakes, unleashing a cataclysmic chain reaction that choked the atmosphere with dust and debris. The result? A mass extinction event that wiped out the dinosaurs and 75% of all life on Earth. That's a sobering reminder of the stakes involved, but it's not just ancient history. In 1908, a smaller asteroid, estimated to be about 120 feet wide, exploded over Tunguska, Siberia. The blast flattened trees over an area twice the size of New York City. The shockwave circled the globe twice. Luckily, the Tunguska Event happened in a remote area, but imagine if a similar event occurred over a major city today. The first step in protecting ourselves from potential cosmic threats is knowing what's out there. The vast expanse of space holds many secrets, and some of them could be dangerous. And that's where NASA comes in. With their advanced technology and dedicated team, they are our first line of defense against these potential threats. They have a dedicated program called the Near-Earth Object Observations Program, or NEOO for short. This program is crucial for our safety. Its mission is to find, track, and characterize potentially hazardous asteroids and comets that could pose a threat to our planet. By understanding these objects, we can better prepare for any potential impact. Think of it like a cosmic neighborhood watch, but on a much grander scale. Instead of nosy neighbors, we have brilliant scientists using cutting-edge technology. These experts are constantly on the lookout, ensuring that we are aware of any potential dangers. They use powerful telescopes both on the ground and in space to scan the skies, searching for any moving object that might come close to Earth. These telescopes are our eyes in the sky. These telescopes are incredibly sophisticated. They can detect even the faintest objects, ensuring that nothing goes unnoticed. They can detect even faint objects, like trying to spot a firefly in the middle of a fireworks display. This level of precision is essential for early detection, and once they find something, they can track its orbit, size, and even its composition. This detailed information helps us understand the potential threat and plan accordingly. One of the most important tools in our asteroid hunting arsenal is the Panoramic Survey Telescope and Rapid Response System, or PANSTARS. This system, located in Hawaii, scans the sky every night looking for anything that moves or changes brightness. Then there's ATLAS, the Asteroid Terrestrial Impact Last Alert System. With telescopes strategically placed around the globe, ATLAS is designed to give us as much warning time as possible if an asteroid is on a collision course. And let's not forget the new kid on the block, the James Webb Space Telescope. This incredible observatory, stationed 1 million miles from Earth, can see farther and clearer than any telescope before it. While its primary mission is to unravel the mysteries of the universe, it also plays a crucial role in detecting and characterizing potentially hazardous asteroids. Once we've found an asteroid, the next step is to figure out if it's a threat. That's where the Sentry system comes in. Developed by NASA's Jet Propulsion Laboratory, Sentry is a highly sophisticated computer program that acts like a cosmic architect, mapping out the trajectories of asteroids for decades, even centuries, into the future. By analyzing an asteroid's orbit, size, and speed, Sentry can calculate the probability of it colliding with Earth. Think of it as a cosmic risk assessment tool. If an asteroid is deemed potentially hazardous, scientists will monitor it closely, refining its orbit and impact probability with each new observation. Leading the charge in planetary defense is NASA's Planetary Defense Coordination Office, or PDCO. This dedicated team of scientists and engineers is responsible for coordinating NASA's efforts to protect Earth from asteroid impacts. Think of them as Earth's first line of defense against cosmic threats. They work tirelessly to develop strategies, technologies, and international collaborations to mitigate the risk of an asteroid impact. They're also responsible for developing emergency response plans in case an asteroid is detected on a collision course with Earth. So, let's say we find an asteroid on a collision course with Earth. What do? This scenario, while it may sound like science fiction, is a real concern for scientists and space agencies around the world. The potential devastation from an asteroid impact could be catastrophic, wiping out cities or even causing global climate changes. Well, blowing it up like in the movies is probably not the best idea. Hollywood makes it look thrilling and heroic, but in reality, it's fraught with risks. That could create a bunch of smaller but still dangerous fragments that could rain down on Earth. These fragments, while individually less destructive, could spread out and cause widespread damage over a larger area. Instead, NASA and its partners are developing a range of deflection techniques, each with its own pros and cons. These methods are designed to alter the asteroid's path without breaking it apart. One promising method is the kinetic impactor. This technique is relatively straightforward and involves sending a spacecraft to collide with the asteroid. This involves slamming a spacecraft into an asteroid at high speed to slightly nudge it off course. The impact, though small, can be enough to change the asteroid's trajectory over time, given enough distance. It's like playing cosmic billiards, using a small nudge to create a big change in trajectory over time. The key is precision and timing, ensuring the impact happens far enough in advance. Another option is the gravity tractor, a spacecraft that would fly alongside an asteroid and use its own gravity to gently tug it off course. This method requires a long-term commitment, as the gravitational pull is subtle but continuous. It's a slower method, but it could be effective for smaller asteroids. The gravity tractor would need to stay in position for an extended period to achieve the desired effect. And then there's the nuclear option, a last resort that would involve detonating a nuclear device near an asteroid to vaporize part of its surface, creating thrust that would alter its course. This method is highly controversial due to the potential for unintended consequences, but it remains a part of the discussion for extreme scenarios. Detecting a potentially hazardous asteroid is one thing, but what happens if it's on a collision course with Earth? That's where NASA's Impact Response Plan comes into play. This comprehensive plan outlines the steps that would be taken in the event of an impending asteroid impact. It includes everything from evacuating populated areas to providing medical aid and restoring critical infrastructure. To prepare for such an event, NASA conducts regular simulations and exercises, such as the hypothetical asteroid impact exercises. These exercises bring together scientists, emergency responders, and government agencies from around the world to practice coordinating a response to a simulated asteroid impact scenario. When it comes to asteroid impacts, time is our greatest ally. The earlier we detect a potentially hazardous asteroid, the more options we have for deflecting it. That's why NASA is constantly working to improve its detection capabilities, aiming to find and track asteroids years, even decades before they could pose a threat. Of course, size isn't the only factor that determines an asteroid's danger. Speed and trajectory also play crucial roles. A small asteroid on a direct collision course could be more dangerous than a larger one that's only going to graze our atmosphere. The good news is that we're getting better at finding and tracking these celestial wanderers. With every new telescope, every new discovery, we're one step closer to ensuring that no asteroid catches us off guard.